Okay, base 10 logarithms. Are we recording? Yep, we're filming. Yes, it's filming, Alex.
All right.
Okay. All right. So I asked you guys to fill these in. So 10 to the 4th. What was 10 to the 4th?
10,000.
Gabby?
10,000.
10,000. 10 to the 3rd?
1,000.
1,000. 10 to the 2nd. Shay? 100. Good. 10 to the 1st. Nate?
10.
10.
Yeah.
10 to the 0. Eric?
1.
1. 10 to the negative 1. Elvin?
Oh,
You didn't do it. Dimitri?
Yeah, I did. 0.01.
Nope. Dimitri?
0.1.
0.1. Thank you, Dimitri. Elvin? 10 to the negative 2nd.
Is it 0.01?
It is 0.01. Negative 3rd. Nate again.
0.001.
0.001.
Can I ask a question?
Okay. Now, negative 4th. You got 1e negative 4, right?
Yeah.
That's right.
What does that equal, Zach? Good. 0.000.
I don't get it.
Okay, well, we'll talk about why. All right. So, do you guys notice any patterns here?
Yeah.
What's a pattern?
Whatever, let's say like whatever, if it's with 10 and it has whatever number it is, that's how many zeros it has.
Okay, so how many zeros? So this number is how many zeros it has?
That's only for positive.
Okay, good. Nice job, Gabby. That's only for positives. Right, that only works for these ones, doesn't it?
Yeah.
Okay? Unless you write the 0 to the left of the decimal. Okay? You always write a 0 to the left of the decimal point. So 0.1, 0.001, 0.001.
You're right.
Okay? Then it works. Okay, but that's good though. Positive number 0. Zach? Good. How many spots behind decimal that we've moved what?
Left. Right.
Right.
The decimal point, right? So these ones are going backwards, these ones are going forwards, right? Right? Positive exponents make numbers that are
Big.
Negative exponents make numbers that are
Negative.
small. None of them are
Negative.
negative. Right? Gabby's on the same track as me. Just because I have a negative exponent, that does not make these negative. Okay? That makes them small. Okay? The reason why is because when I do exponents, if I do 10 squared, let's say I do 10 to the 1st. What does that equal? 10. That's why I get 10 right here, right?
Yeah.
10 squared is 10
Zero.
times 10. Right? Which gives us 100. 10 to the 3rd is 10 times 10 times 10, which gives us 1,000. Good.
So
Yes, Gabby.
Okay.
Yeah.
So what if the 10 was negative?
We'll get to that later. Okay? All right. 10b, we're focusing just on positive 10 right now because what we're getting to is what's called logarithms base 10. So we're only working where our base is 10. And base being 10, we'll get to in a little bit. Okay? So, good question, though. So when we have positive numbers, that means we are multiplying, right? What do negatives do? Divide. So if I have 10 to the negative 1, what does that mean?
It's divided by 10.
It's
10 divided by 10.
1, right? Because 10 to the 0 is 1. It's 1 divided by 10, which is 0.1. 10 to the negative 2 is 1 divided by 10 times 10, or 100. Okay? 10 to the negative 3 is 1 divided by 10 times 10 times 10, or
10 to the 3rd.
1,000. That's why this, we'll write these all out real quick. That's why this is called a tenth, because it's 1 over 10, right? It's a fraction. This is called a
100.
hundredth, because it's 1 over 100. And this is called a
1,000.
thousandth, because it's 1 over 1,000, right? If it's 1 over 5, it'd be 1/5, right? But since it's 1 over 10, it's 1/10 or a tenth. 100th. 1,000.
Sweat.
Not quite. ISS's.
Ooh.
All right. So, what's the pattern here? Hey, take it easy, Ellen. Okay, what's the pattern here?
That hurt, Elvin.
Yeah. That's what we
Gentlemen, we're recording, remember. Okay. So, the pattern. Positive exponents make our numbers bigger, right?
Yeah.
Yes.
So they move our decimal which way?
To the right.
Right.
They move our decimal to the right. Okay? Negative exponents make the number
Smaller.
smaller, so they move the decimal place to the left. Okay? So that's our rule. Positive exponents, 1.0, they move us to the right. Right? They move 1.0 to the right. So I get more zeros. Right? Make the number bigger. Right? Negative exponents move us which way?
To the left.
Negative move left. So like 1.0 becomes smaller. Okay, does that make sense?
Yup.
Right? So the exponent is basically how many spaces you move the decimal point to the right or the left. Right? So you can, and I guess have more room than what I have right here. So you can write exponent equals the number, not hashtag, number of spaces we move the decimal right, which is positive, or left, which is negative. Right? Any questions?
It's awkwardly silent,
What'd you say?
though. It is awkwardly silent.
Hey, it's a little out of character for us, huh?
This is gonna be your best.
Should act like we're filming every day. All right. So,
Oh.
what is x? What is x if 10 to the x equals this? Okay, take a moment. I want you to think about it. I want you to look at it. All right. What is x if 10 to the x equals this? Okay. Alvin, what do you think?
It's 6.
It's 6. Gabby, is that you got 2 is 6?
Yeah, but can I do B?
We'll get there in a second. All right. So, why is it 6?
Because
Well,
there's 6.
if I start with 1.0, so let's say I start here with 1.0, right? I have to move this place 1, 2, 3, 4, 5, 6, right? And since that number is a big number, we know the exponent was positive 6. Thank you, Shay. Right? B, what'd you think, Gabby? What'd you get?
10 to the power of negative 8.
Nope. Oh, no, you're right. You're right.
Wait.
You're right. I'm sorry. Gabby, you are correct. Okay. So we start here at 1.0, right?
That was when it gets arguing.
Gabby's going to start throwing stuff at me. All right. We start here at like 1.0 and we move this way. 1, 2, 3, 4, 5, 6, 7, 8. So Gabby is correct. Now, is this a positive 8 or a negative 8?
A negative.
Negative 8. Does that make sense? Are there any questions about that? Any questions?
No, sir.
None?
Not at all.
Okay. So,
You ever answer the questions that are on the YouTube video? Like in the
people
comments?
post in the comments?
Yeah.
Yeah, I have. Okay. Not a lot of people ask questions in the comments, but it happens. All right.
I'm subscribed to you.
You are?
Yeah, I subscribe to you too.
Okay.
I did not.
Sweet.
Did I ask
All right, guys.
all?
So,
Where you going?
I'm just copying down the little chart you guys made already. Now here it says approximate x when 10 to the x equals 345 and 10 to the x equals 0.025. So take like a minute, and I just want you to try to approximate. When I say approximate, just try to figure out which numbers the power will be between. And if you know what numbers the power is between, then actually try to figure out the power, what power it is.
I love this dude at 45 zeros.
What?
He said number one is x equals 10 and 35.
345. X does not equal 345. Because we're trying to find what x equals to give us 345. Okay. You hate math. Awesome. Spreading the hate of mathematics. That's my job.
Now I see what you mean. I see what you mean now.
All right. What? All right.
Hold on, wait.
I got really close to it.
Come on, time here. Come on. A little time crunch. Got to make a video short enough people still watch it. I'm just joking. Does anybody know where we should start? What number should we start with?
I got the
Alvin, you think you know?
400.
2.5.
At 5?
2.5.
You think 2.5, Gabby?
2.5.
Okay. Gabby, why 2.5?
Maybe I lied.
Okay. No, you're right.
Oh.
345 is between which numbers on this chart?
100 and 1,000.
100 and 1,000.
I was right.
345 is somewhere in there, right? So that means our exponent's going to be between which numbers? Between 2 and 3. Okay? So
Make it 2.3.
2 is less than x, which is less than 3. So we could try a bunch of things, and you might be here all day because there's a bunch of options for between 2 and 3.
2.3.
Okay? But the answer is 2.535.
They don't like
I had 2.5. I had 2.5.
I'll put down my calculator.
2.535.
I had 2.5.
So if you do 10 to the 2.535, then you get like 345 point something. Right?
That's not right.
It's pretty close.
I got 342.
Yeah,
I
342. Really?
Yeah.
You said 2.535, right?
Maybe I wrote down the wrong number last hour. Okay, okay, well, there, 3, 4, 5. Oh, 2.537. Yeah, read my own handwriting. Sorry, guys.
That's still 344.
344 in some decimal, right?
Yeah, but it doesn't round.
Okay, put an 8 at the end then. 2.5378. Man, you guys are a tough class today. Is that better?
Well. Yeah.
Yeah. Okay.
You know how hard it is.
Still
The other one. Where's .025? What number is this between, Elvin?
Is it between the hundredths and tenths?
The hundredth and tenth. Yep, it's in here. Okay. .025 is somewhere in here. Right? So that means that -1 is less than x, which is less than -2. Alright, when we did this last hour, I got, what was it? -1.602. Okay. Now, when you plug these in, are we getting exact answers? No, when you plugged in 2.5378, it was a decimal, wasn't it?
Yeah.
When you plug in -1.602, you get a decimal. Well, that's a decimal anyway. But you get one that's not exactly .025, right? So what we're trying to figure out, guys, is can we determine the exact value of x?
No.
That's what the goal is. Okay. To do this, we got to use a log. Okay, not one you start a campfire with. Okay.
Oh, log.
We got to use log. Now on your calculator, if you find your number 7, we're find number 7.
Oh, my.
Okay. And right to the left of number 7, that's the log key. Okay? If you hit that button, your log will fall from this thing and hit you in the head. I'm just joking. Okay, it would be nice though, right? Everybody hit your log key now. Alright. No, it's not that kind of log. It's a different kind of log. Alright? The log, what a log stands for is logarithm. A logarithm finds the power you raise a number to get another number. Okay? So, we'll go through a little bit, Zach. I'm kind of scared. Okay? Now, when we're dealing with logs, we're trying to find exponent values. So we need to talk about what powers and exponents and all that stuff is. The base, guys, is the number raised to the power. So down here, A, C, and B, which one's the base?
A.
A, because A has a power on it.
So what you're saying is we have to be all about that base?
No. Power. The exponent, the exponent number is raised to. Okay. Power is the exponent number is raised to. So which one here is the power?
C.
C, right? Right? C is the power, it's an exponent, right? When a base is raised to power, we get a product.
That's B.
That's B. Okay? So A is the base, C is the power, B is the product. B is the result of raising it to the power. Okay. Oh, wait. Yes, you need one. So-
I write down that.
Yep.
AC would be.
A to the C equals B. So in our example, this example right here, what's the power?
5.
5, Yvonne. 5 is the power. Right, Taylor?
Yes.
What's the base? 10. And what's the product?
The answer.
100,000. Okay? So, this is the base. This is the power. This is the product.
So, that kind of makes sense.
Now the logarithm,
So I said, what does log have to do with anything?
or log, short for logarithm. The logarithm product determines the power the base was raised to. Okay? So if I take the log base A of B, then I'll get C. Okay? Because B was my product. So if I take the log base A, because A is my base, if I take the log base A of B, then it'll tell me C. Basically, it tells me what power, log of B, tells me what power I need to raise A to get C.
So let's say it's like you're trying to find out what x is.
Yep. So we were just talking about 345, right?
Yeah.
So if I do the log of 345, your calculator is set up to do log base 10. So anytime you hit log, that's doing base 10. So it's seeing what power you raise 10 to get 345. So you do log on your calculator, That's the power you raise 10 to, you get 345. So do log of 10, log of 345, what do you get?
2.53781945.
Okay, keeps going on, right? The same number I just told you, wasn't it?
You're right.
That's all I did to figure out was the log of 345.
You cheated.
We did it last time, right? We did the same thing last
So
time.
if
You
it
cheated.
gives you the
It's
C
okay.
and you're looking for the X and you type in log,
No, it gives you the B. 345 was our B, because we were doing 10 to the X equals 345, right?
You're right.
They gave me the B, I wanted to find the X.
so if you have the B, you gotta find the X to find the C.
Times the power you raise 10 to get that number.
So let's do it.
Okay. So when we had the other one, it was 10 to the X equal 0.025, right?
How do you want us to round,
So-
sir?
4 digits, 3 digits.
After?
Okay. On a test or quiz, I'll tell you how many you need. All right. So log base 10 of 0.025 will figure out this X. So log of 0.025, type in calculator log 0.025, and what do you get? Negative 1.602. Right? Now, the more we round, the further our answer will be from the right thing. Okay? So if I plug in negative 1.602 in here for X, I'll get something close to 0.205. But the more digits I keep, the closer I get to 0.025. Okay? Are there any questions about that?
So
What? Okay. The stuff on the left side?
so
Just writing it down.
like the
So what we're doing here, guys, is what's called the power property of logs. All right, so right here, the power property of logs. This is basically exactly what we were just talking about. Okay? Now, I don't have a space for this on your notes because I want you to write the power property of logs. This phrase right here, log base A of B equals C if and only if A to the C equals B. I want you to write that somewhere on this paper where you are going to see it. Because that's the main point. Okay? What's that, Gabby?
Is there a song?
There is a song, and we will watch it tomorrow.
Yes.
Okay? So I'll show you the song later.
Sorry, Gary.
In fact, actually, someone wrote their own song with their own tune and everything for the song. I'll show you. Okay. What? The power property of logs. This right here. Log base A of B equals C if and only if A to the C equals B. Okay? And Gabby, if you Google power property of logs song, then you'll
wait, A
you'll
equals
see
C
it.
equals
Log base A of B equals C if and only if A to the C equals B. It's the same thing we have written down already. Okay? So, let's guys write down. And here's a little thing for your calculator. Log on your calculator is already base 10. So if you do log on your calculator, you're finding the power you need to raise 10 to get that number.
what?
If you do log on your calculator, you're finding the power you need to raise 10 to get that number.
Right.
So if I do log of 345 on my calculator, I'm finding the power I raised 10 to get 345. Okay? It's not log base 2.
Okay, is it like on this chapter we're gonna learn something different?
No, later on, in next year or the year after, you'll learn how to change from 10 to log base 10 to log base 3.
That's it?
Well, or other ones.
Okay.
Okay, or base 100, or base 1,000, or base 4, or base 2.5, whatever they want to do. Okay. All right. So here is the power property of logs. Log of 100 equals 2, right? Because if I do log on my calculator, the base is already what? 10. Right? So that means log of 100 equals 2 because 10 to the second equals 100. Right?
Sure.
On your calculator, type log of 100. What do you get?
2, I understand.
You get 2. Right? The reason why you get 2 on your calculator is because of this part right here. This is why you get 2 when you do log of 100. Okay? Because if I take 10 and raise it to the second power, I get 100.
Okay.
Okay?
Nice.
Same thing if I do the log of 550 on my calculator. Do log of 550 on your calculator.
2.740.
2.74004, right? Right?
Yeah.
The reason why when you do log of 550 on your calculator, the reason why you get that is because 10 to the 2.74004 equals 550. Okay? If you don't believe me, try it out and you'll get something close to 550. Alright, if you do this part here, you get something close to 550.
Do you think it'll go 4 plus this chapter? Can't go 3?
No, the further you go,
Then more.
the more exact this will be.
Alright.
Okay, that's what I get when I did my calculator. It's close to
I
550.
got 549.5.
Okay, if you get more digits, then you're gonna get closer to 550. Okay.
Like copy.
All right. Any other questions? Any other questions?